Excuse me. Excuse me. Short URLs such as TinyURL. It's not a class encode a URL and decode a TinyURL. Oh, that's interesting. So, so we take a long URL, we end up with a short URL. And we take a short URL and end up with a long URL. That's kind of nifty. No restriction on your encode decode should work. You just need to ensure that a URL can be encoded to a TinyURL and the TinyURL can be decoded to the original URL. Huh, that's kind of nifty. Initialize the object of the system. Encode, TinyURL, decode returns the original. Guaranteed given short URL was encoded by the same object. LeetCode problem design. TinyURL output. Turns TinyURL, decode, turns the original URL. Okay. I mean, first off, spelling, come on. Missing an A in there. And second, I think this is like kind of a nothing question because it's sort of arbitrary. But I do want to see what the discussion says. So we'll throw my hat in the ring here and see what ideas I can come up with as far as an encoded URL. So with an encoded URL and a decoded URL, basically, really what they're asking for is an algorithm, a formatting algorithm that would reduce the size. Excuse me. So, I mean, we can just put, you know, the short URL. We can do exactly what they have here. This tinyurl.com could be the first part of the string always, but then this part, I guess you could use a kind of hash function. I don't know. I mean, one of the ways to do this is to use each letter. It's compression, right? Excuse me. You can use a kind of compression algorithm where you take the number of characters and how many there will be. So H1, T2, P1, S1, :1, /2, L1, E2, 1T, 1C, 1O, 1D, 1E, 1 dot, and you can compress in that way. I mean, that's not a particularly good way of doing things in my opinion. But it's interesting that this is like this is a tiny, I mean, look at that. Talk about compressed. There's a whole URL in there. Yeah, it's very compressed. I mean, you can technically store the, you can just store the string in a hash map that's stored in this object. You know, that would technically work, but that's probably not the best way to do this. You know, that seems kind of bad. This is basically just a compression scheme of some kind. I don't know. How could you shorten this? Another way you can handle this would be like to convert this to a different base, maybe like hexadecimal, and then compress the hexadecimal string. And you can do it that way too. I don't know if that's much better though. Like you could say each character is an integer, and that integer can be converted to a hexadecimal, and then you could have. I actually don't know if that's better. I'm not sure. I was thinking you want to do something with the bits, like maybe you convert it down to binary somehow, and then convert that to something else. I gotta think about this for a while. Well, a few things to consider. So you could consider this to be a number base 26, in which case it's a pretty big number. But yeah, you could consider this to be a number base 26. And actually, no, not base 26. You have other characters in there too, so it's more than base 26. So it's a number with a pretty large base. You could consider it that way. If you convert it to ASCII, it's a really big base, a really big number. But you could offset that ASCII a little bit depending on the available character set, but it's really any ASCII character, so I guess it is just the ASCII set is the base. So this is a number. That's a pretty big number, actually. That's quite a large number then. Well, can we convert that number to a smaller number? Compress that somehow? Excuse me. I don't really know. Don't really know how we can. Yeah, like I said, this is ultimately a kind of compression algorithm. I wonder if you could just convert it to zeros and ones. Convert each character to its ASCII value. Each of those numbers are represented as integers with 4 bytes, right? 4 bytes, 32 bits, integers, and then you can convert those into. You can convert them into hexadecimal values, but that actually would make the string longer because it would be each hex character will give you. Excuse me. Each hex character would give you 2 characters, or rather, yeah, each integer would give you 2 hex characters rather than. So you'd actually have the string would be twice as long. Yeah, interesting. I mean, you can do that. That's not very good though. That actually increases the length of the string rather than decreases it. But one idea is to maybe take something like that and then compress that using the compression algorithm that we described before. So, if you see repeated sequences of numbers, then you can sort of make those into 2 characters. But that doesn't guarantee it's going to be smaller. And similarly, like you could do that with binary. Like you could break this all the way down to bits if you wanted to, and then compress the bits. But again, that means that every bit is going to give you a character potentially, which is not really, I guess, what you want. I think the only way to really do this is to actually create some kind of a hash scheme or something. And yeah, basically you just create some random string and that's a hash key. And I think it's the only way to really do this. You just have to store the hash key. Interesting. I don't have an answer. I actually don't know. Aside from using a hash key, I really don't know. Oh, ouch. Ooh. Just cut myself unnecessarily. And that was the worst spot to do it too. My skin is, I guess, healing from some wound. I keep touching it, poking at it, messing with it. Making it worse. I guess the question is, how do I live without you? What am I looking for here? What are we doing? Sorry, I don't even know what I'm trying to do. I don't even know Just let my mind kind of wander. Yeah, I don't think converting to bits or even hexadecimal and then compressing. I mean, really, if you're going to compress at all, you should just compress directly on the characters here. I guess you could come up with a scheme where, like, you could use a larger character set kind of a thing. If you really wanted to. I really think using a hash map is really the only way to do it, quite frankly. I think that's it. I think you would just have a database of all these URLs that you're encoding, and on the back end, like a hash set, a hash map, or more or less. Yeah. Try to make the keys unique. The URLs. I guess you could ensure that it's unique. Could just generate another random string if it's not unique. Actually, you can guarantee uniqueness by taking a number and converting it to hexadecimal, and then just incrementing that number each time you need a new URL. And those are your hash keys, so those are guaranteed to be unique. And if that number gets too big, then start converting it to something else, I guess, or I don't know. I mean, hexadecimals. You kind of a lot. You can kind of have a lot of strings. I guess I'll do that. I mean, that's reasonable. That's one way of doing it. I like that. I like that. That's okay. All right, we're gonna do this. This is not the best way to do this, but you can do it this way. Excuse me. So we want a string to a string. Call it map. And we're going to say int count equals 0. So we're going to say plus count. We actually don't want to give an integer. We want to convert it to a string. I guess you could convert it to ASCII, an ASCII string. I don't know if that's a good idea. I guess probably hexadecimal is probably better. There's a way to, there's like a 2 hex. I mean, I can convert it myself, but, well, actually, we can write our own. Could write our own, it's fine. So we're gonna say string ret for, do the following. Oh, this is, by the way, of an int to a character. I think we could do it this way. I actually don't know if we could do this. Hopefully we could do it this way. Actually, no, that's not even, I take that back. I don't need that. I don't even need it, but I don't know if we could try that just to see if it works. I actually don't even need to use this. Let's just see if this compiles. I'm curious what happens here. How are we doing? We got 21 minutes in, okay. Oh, we don't have a name. Let's call this X. So this does compile. So what happens if we... did that wrong? Oh, that's really interesting. So you can set up an initial map like this with a bunch of pairs. It'll work. It'd work. It would work. Very neat. But we don't need that. So we're going to say for int k equals count. And actually we want to use a very large integer. As long as k is greater than or equal to 16. We're going to divide equals by 16. And we're going to say if, we're going to say int digit equals k modulo 16. So if, actually we should say long. If digit is less than 10, ret plus equals, it's going to be a character. Take digit, and we're going to subtract 10, and then we're going to add 0 to get the character code there. If digit is greater than or equal to 10, and if digit's greater than or equal to 10, then we're going to do a similar thing. But we're going to add a and also subtract 10 now. Actually it's just going to be plus. Less than 10 we just add 0, so we get the 0 digit. Otherwise, if we're greater than or equal to 10, we subtract 10 and add a. Yeah. And you do the same thing for oops. Okay. Now we're actually going to say long. And we're going to use k here instead. So we can use similar logic for converting to hex that we used for building a digit string. So yeah, so we do that, and then we just have to set that up in the hash map. So map or hash map rather. So hash map of ret is going to be equal to long URL and return ret. So it gives you your key, and then here you're actually going to get yeah, equals long URL, and you're actually going to get, whoops, didn't mean to do that. You're going to get, you know, TinyURL. Concatenated with ret. And then we're going to return I guess key is going to be short URL dot substring of, we don't even have to count, we could just say this string dot size of the other short URL and return hash map of the key. Something like this. Something like this. Not a structure or union. Excuse me. Could make a string out of this. Something like this. There we go. Do we just go for it? I guess so. I mean, why not? Let's see what happens. I'm curious. Hey! Oh, it's fast too. Nice. Use a little bit of memory though. I don't know what this should be really. This is one way of doing it. Probably not the best way. 30 minutes we spent on this. What did the discussion say? This is one way of doing it. Probably not the best. True stateless 1 in C++ joke. 2 solutions and thoughts. Easy solution in Java. Easy map solution. 3 different approaches in Java. Use 2 dictionaries explained. 2 dictionaries. Really. First solution produces short URLs. Hey, that's what I did. Hey, sweet. Sweet. Oh, he just creates a list. Wow. Wow. That's even easier than the hash. I was thinking, well, we can create a hexadecimal hash first. You know, that way you get, instead of just getting numbers. Asked to encode the same long URL several times, it will get several entries, waste code and memory. Oh, I didn't think about that. Find out how many URLs have been encoded. Not sure I want them to know. Fair enough. Special numbers by spamming the repeated request shortly before the desired number comes up. Only using digits means the code can grow unnecessarily large. Only offers 1,000,000 codes with length 6 or smaller. Using 6 digits or lower uppercase case letters would offer many more codes. Yeah, I mean, true. True. I mean, I just used a hex. I figured a hex number is pretty reasonable, right? Because you get 16 raised to whatever power. Following solution doesn't have these problems. Produces short URLs. Random code of 6 digits or letters. Long URL is already known. How long ago did he solve this? 2018, 3 years ago. Codec. Alphabet, string, ASCII letters. The long URL is already known. Short and existing short URLs used and no entries generated. I didn't even think to do that. It's a good idea. It's good. It's good. URL to code, code to URL. Oh, so 2 different hash maps. Interesting. You don't actually need 2 hash maps to make this check though, because you can do this check with you can do this check with, why is 2? You can do this check with oh no, I'm sorry. I take it back. You do need to use 2. That makes sense. Yeah, that's fair. Because you'd need to. That's fair. Never mind. I take it back. I take it back. I take it back. You're right. You do need to use 2. That's fair. Didn't even think to do that. And this one creates random. Oh, that's interesting. Random choice join. Oh, I like that. This code. It's not in there. And set it. And then return this. That's clever. I like that. I wouldn't have done this though, personally. I guess you could do, yeah, I mean, you could write a loop like this, but there is a problem with what he just did here, by the way. It's just very subtle, and that's why I didn't do it. Oh, there it is. Never mind. Never mind. Another random code is generated instead. It's possible the randomly generated code has already been generated before. Oh, there's a while loop. Ah, yes. I didn't see that. Okay, never mind. Okay, got it. You caught it. I didn't even see that was the while loop there. Very good. Yeah, this is what I was thinking about doing too. Actually, something very similar to this. You could build this string, and then you can just basically generate random indices into the string to generate the characters for the code, and then you just keep trying again if you've already tried that code, and you can use as many letters as you want for the code, and yeah, it just gets dumped into a hash map. Dumped into a hash map, which really should be like a database, because if you have, if you have like tons and tons and tons of these codes, then you don't want them to just be sitting in local memory in a hash set. You probably want these written to a database, and then also probably written in a backup file somewhere, so that way if the database ever gets turned off or whatever, what have you, if somehow the database can recover what's in it. Yeah, interesting. Interesting. It's possible the randomly generated code has already been generated before. In that case, another random code is generated instead. Repeat until we have a code that's not already in use. How long can this take? Well, we get up to using half of the code space, which is a whopping 28 billion entries. Each code has a 50% chance of not having appeared yet. Expected average number of attempts is 2, and for example, only 1 in a billion URLs takes more than 30 attempts. And if we ever get to an even larger number of entries, and this does become a problem, we can just use length 7. We'd need to anyway, as we're running out of available codes. Fair enough. Yeah, okay, I like that. That's fine. Probably what I should have done. Thought about doing something similar to that. True stateless one in C++. In Java. Much better compression rate. True stateless. Oh, I see. If you encode it, you just get the long URL. You just get the long one, and then when you decode, it's the same long one again. Oh, that's funny. I didn't think about that. So basically, not shortening the URL at all. That's funny. Much better compression rate. Go to empty returns v, stores v. Well, that's not gonna work. That won't work. Lamau. That just doesn't work. I mean, I guess it works if you. I guess it works if, right, if you're just encode, decode. Yeah, I guess it does work. If you're only encoding and decoding one at a time, it's a similar approach. It's very funny. It's a funny joke. Pass this code. Meet this problem interview. Will you use this answer? Yes. Of course. As long as it got passed, it's no longer a joke. One judge. Should check whether it's actually shorter. I use this to pass the judge too. What's wrong with these people? Inspired a Python solution and a JavaScript solution. Oh man. Oh wow. Oh wow. Yep, it's fantastic. Wow, it's got multiple pages of reviews here. What a joke. What a joke. You've got to be joking me. Is this some kind of joke? You think this is some kind of joke? You think this is some kind of joke? What a joke. 2019. I gotta give it a couple more to make it to 2021. I like Stefan Pachman's. This is probably the best. I'm thinking about it. This is better than what I did. What I did is okay, but not ideal. Not ideal. Converted to hexadecimal. Well, actually, I think what I did is pretty good. Yeah. I like what I did. Because you're going to get a short string, relatively short. You don't need a hash set. I mean, you do need a hash set. You're never going to get a duplicate, so you don't have to check for that. You will get several entries for the same URL. That's true, which does waste some memory, but you can find out how many have been coded and encoded. That's fair. So, yeah, I guess these two problems I still have. Special numbers by spamming with repeated requests shortly before their desired number comes up. Yeah, it could be fair. Only digits can grow very large. Well, mine's not too bad. I kind of fixed this one. Yeah, I like the other solution better. Yeah, that's fair. There are some issues. Yeah, having the same long URL a few times. I guess you could have a hash set that just checks to see if you've already encoded that URL. Just have two hash sets, and then just if you have already, then just return the same one again. Return the one that's already in there. You can find out how many URLs have already been encoded. You can jump ahead a bit, like randomly, you know. I don't know if that's a good idea though. Yeah, this is a difficult one to face. Special numbers too, by spamming. Yeah, I guess these two are kind of hard if you don't use totally randomized strings. I would do what Stefan did. Yeah, that's the other. I had thought about these two options. This is the one I went with. This just seems like the simplest. And then what Stefan did is another option. The tricky part though is that you're using state for this. So. Meaningless to promise the same long URL to be shortened as the same short URL. Do the promise and use something like hash to check existing. The benefit is much less than the cost. Oh, he's saying it's not really worth trying to make sure. I see, yeah, that's fair. So repeated URLs are fine, is what he's saying. That's interesting. Why is it meaningless? Old TinyURL has been generated, but in some web page will be invalidated, which may not be expected. TinyURL.com actually do preserve the previous generated TinyURL for the same long URL. I think they do that for a reason for performance. I guess it's just a matter of coming up with an efficient SQL query. A long URL exists as a hot URL that will likely be hit. Oh, I totally misunderstood. I don't understand both what either of these guys are saying. I want to say like either he's saying it's meaningless to to invalidate the other. They're not invalidated if you. I don't know if he's talking about multiple entries or what. I don't know what they're talking about now. I just don't understand. Same long URL to be shortened as the same short URL. Excuse me. I don't know what he means. I don't know what this means. It needs to English needs to be a little bit clearer about what both of them are talking about. It's a joke, not answer. Is it? I don't know. Cannot declare any array list. There is no state being saved in the program. Joke. Are you sure? I don't know if that's true. I think you can do this in Java. Maybe I'm wrong, but this would be. Oh, it has to be private. I mean, it needs to have. Well, I don't know. Is it private? I think there's a default, right? I actually don't know. I don't know. Let's see if we can do this in Java. Let's find out now. Yeah, it works. Huh. Interesting. No, I don't know. But yeah, apparently this is how they do it in industry, quote unquote, which is just exactly what Pachman had the first time. I think what Pachman was saying is probably better. I think it's better to use the hash maps rather. All right, let's get on with the next one. This is a lot of time to think about this question though. A lot of time to ponder it. I think I did okay with my solution. I think I did alright. You'd basically have to pick up that it's hexadecimal. Oh, you know, I didn't even think about that. That the first few would show. Actually, the first few would show that it's what do they call that? That it's a that it would be 1 through 9. So it would be pretty clear that it's hexadecimal. But that's all right. That's all right. Yeah, it's not the best. It's not the best. I think what Pachman did was better. I don't like it. I don't like what I did. I think it's like kind of questionable. Anyway, that's fine. We don't need to hang on this for too long. Yeah, it's the same thing that Bachman did. Also choices in Python, I haven't seen that before. Yeah, we're looking for the choices in Python. Whoa. Also, how are we doing on time? 45 minutes. Yeah, man, I spent a lot of time just kind of looking at stuff. I don't know. I like to learn things. It's not very good. This is so annoying. Can never find what I'm looking for, man. Choices. Oh, okay. K-size list of elements shows the population with replacement. Okay. So random choices, got it. Oh, and you can give cumulative weights too. That's interesting. Very interesting. So we have shuffle, we have choice, rand in, rand range, rand bits, sample. Excuse me. Without replacement. Okay, gotcha. Pretty interesting stuff. Okay, I think I get it. So that's in the random. It's part of the random library for Python. Got it. Okay. All right, we're gonna stop on this problem now. This was an interesting problem, but it's time to move on. So thank you for watching. Appreciate it. I will talk to you soon. Have a good rest of your day, your night. I guess I don't know if I want to go for like another couple hours or something. I'm not sure. So yeah, thanks again. Talk to you soon.